March 12th, 1942 North Atlantic. The sea was on fire. Convoy HX-178, bound for Liverpool, was under attack. German U-boats sliced through the freezing swells like steel sharks, their periscopes flashing briefly before another column of water erupted skyward. A Liberty ship, the SS Patrick Henry, staggered as a torpedo tore through her hull. Men scrambled to lifeboats, faces lit by the red glow of burning oil. Overhead, a Navy destroyer escort the USS Jacob Jones, DD-130, fought to protect the convoy. Her sonar pinged through the chaos, but the North Atlantic was merciless. At 0515 hours, a torpedo slammed into her stern. The blast lifted the 1,200-ton ship clean out of the water. Within minutes, the Jacob Jones slipped beneath the waves, taking nearly her entire crew with her. On the eastern seaboard of the United States, word spread fast. Destroyers, the Navy's shield against the U-boat menace, were being lost faster than they could be built. In Washington, Navy planners stared grimly at the numbers. In the first 3 months of 1,942 alone, the U.S. Navy had lost more destroyers than it had built in the previous 6. Admiral Ernest King, Commander-in-Chief of the U.S. fleet, leaned forward over a map of the Atlantic and muttered the words that would set history in motion. "We're fighting an industrial war now. If we can't outbuild them, we lose." Bath, Maine, April 1942. Snowmelt poured down into the Kennebec River as the Bath Iron Works yard came alive with the clang of hammers and the hiss of cutting torches. This wasn't a new shipyard. Bath had been building ships since the Civil War, but it had never faced pressure like this. The Navy needed destroyers, dozens of them, fast. And they had chosen this quiet New England yard to lead the experiment that might save the fleet. William Bill Newell, a wiry mechanical engineer with horn-rimmed glasses and sleeves permanently rolled above his elbows, stood atop the main slipway and studied the skeletal hull of Hull 240, a Fletcher-class destroyer that, by every rule of shipbuilding, should take at least 120 days to complete. But he didn't have 120 days. He barely had 3 weeks. Inside the yard's drafting office, the air smelled of coffee, ink, and adrenaline. Blueprints sprawled across every desk. Men and women, many of them new to shipbuilding, leaned over the drawings, tracing the intricate web of frames, bulkheads, and rivet lines. Newell slammed a hand against a wall-mounted chalkboard. On it, a single number was written in bold strokes. Chinook, 16 days. That was the challenge he'd set to assemble an entire destroyer, fully armed and ready for sea trials, in less than 3 weeks. When the Navy delegation from Washington arrived to inspect the yard, they thought it was a joke. Rear Admiral Samuel Robinson, head of the Bureau of Ships, reportedly told Newell, "You're asking us to believe you can weld a 2,000-ton warship together faster than we can bake bread for the fleet." Newell didn't flinch. "Then, Admiral," he said, "you'd better set the oven to high heat." The Bath method. To pull off the impossible, Newell proposed something radical to apply assembly line production to warship construction. It was an idea inspired by Detroit's auto plants, where Ford was already churning out bombers at Willow Run. But no one had ever tried it on a steel warship, something that required precision alignment of hull plates within millimeters, thousands of electrical systems, and a labyrinth of pipes that could stretch for miles. Traditionally, shipyards built a destroyer sequentially, laying the keel, adding frames, plating the hull, and then installing the internal systems. A process that crawled, often taking half a year or more. Newell's plan flipped that on its head. He divided the Fletcher's design into modular sections: bow, midships, engine compartments, aft sections, superstructure, and had each one built simultaneously, in separate fabrication shops scattered across the yard. Each module would be pre-wired, pre-piped, and pre-fitted with its own machinery. Once completed, massive cranes, some newly built for the task, would lower the sections into place like puzzle pieces, welding them together with near-surgical precision. It was bold, risky, borderline insane, but it was the only way to meet Admiral King's impossible demand. April 20th, 1942, Day 1. At dawn, a whistle pierced the mist above the Kennebec. Welders, pipe fitters, and riveters surged into the yard over 7,000 men and women, many working 12-hour shifts, 7 days a week. They weren't just building a ship. They were fighting a war of minutes and inches. Teams in the hull shop welded 30-ton sections by floodlight. In another corner, electricians unspooled miles of copper wire, threading them through steel conduits before the sections even touched water. Women in overalls rosies from across Maine assembled fuse boxes, electrical relays, and communication panels, stamping them with small metal tags that read BIW 1000, 942. Every hour was tracked on a massive clock inside Newell's office. When one section finished, another began. When a mistake was found, it was logged, analyzed, corrected, not punished. Speed means nothing without precision, Newell reminded his crew. A ship built wrong at sea is a coffin. A ship built right is a weapon. By day 8, the yard was unrecognizable. Cranes swung overhead in a synchronized ballet. Forklifts roared between sheds, carrying entire bulkheads like slabs of meat. Reporters from the Portland Press-Herald were turned away at the gate. Security was tight, and rumors had already begun circulating that Bath was attempting to break every naval construction record in history. By day 10, the hull of Hull 240 had already taken shape, sleek, sharp, and hungry for the sea. Welders called her the Greyhound. On the 11th night, snow began to fall again. Sparks danced against the white as the final hull plates were lowered into place. A young welder named Joe Cavanaugh wrote his name inside the hull with chalk before sealing it forever in steel. He would later say, "We built her so fast, it felt like she wanted to be born." April 28th, 1942, day 16. At 0430 hours, a bell rang through the shipyard. The last weld was struck. Floodlights bathed the destroyer's hull as work crews stepped back, faces smeared with soot and pride. The Navy brass had been invited to witness the moment. As the destroyer slid down the slipway and kissed the water, Admiral Robinson turned to Newell, stunned. "You built a Fletcher-class destroyer in 16 days, he said. "How in God's name did you do it?" Newell just smiled. "We didn't build a ship, Admiral. We built a system." The destroyer was christened USS The Sullivans, DD 537. Though its official commissioning came later that year, the speed record was real, the methods revolutionary, and the message unmistakable. America's shipyards could now outbuild the ocean itself. But Bath Iron Works was only getting started. Bath, Maine, May, 1942. Morning fog clung to the river as the newly christened USS. The Sullivans floated at her pier, her grey hull still steaming from the heat of fresh welds. She was alive, humming with the low mechanical growl of her General Electric turbines, the metallic ping of her boilers warming for the first time. Inside the shipyard's administrative building, the atmosphere was electric. Telegrams were pouring in from Washington from the Bureau of Ships, the Navy Department, and even the White House. Unprecedented achievement. Replicate Bath process immediately. This is the war's turning point in industry. William Newell, who hadn't slept more than 4 hours in 2 weeks, leaned against his office window and stared down at the destroyer that had changed everything. But beneath the pride was exhaustion and fear. They had done the impossible once. Now Washington wanted them to do it again every time. The challenge of scaling a miracle. In the following months, Bath Iron Works faced a dilemma. One record-breaking ship was impressive, but to win the war, they'd have to build dozens using the same radical system. Newell's modular method, now called the Bath process, depended on a delicate choreography of timing and logistics. Every weld, every section, every cable had to be built in parallel, then merged within a precision window measured in hours, not days. But with wartime expansion came chaos. By summer 1942, the yard had tripled its workforce to over 20,000, drawing in men and women from across New England. Many had never seen a ship before. Some were farmers, others housewives, mechanics, even students too young to fight overseas. Training halls ran day and night, teaching recruits to weld, rivet, and read blueprints in less than 2 weeks. The roar of acetylene torches echoed through the town day and night. Locals joked that Bath had become the city that never slept because it was building ships while it dreamed. Inside the steel cathedral, walking the yard by floodlight was like stepping into a living organism. Each fabrication shed pulsed with its own rhythm sparks, cascading from welding arcs like fireflies, cranes lifting hull sections that groaned under their own weight, foremen shouting over the clang of steel. In the foundry, molten metal hissed into molds for propeller shafts and gun mounts. In the wiring sheds, teams of women worked with delicate precision, threading copper through conduit systems that would soon power radar, radios, and weapons. Each part, every gauge, every pipe, every bracket, was stamped with the same letters. Biu. It became a mark of pride, the promise that no matter where a sailor served, whether in the Atlantic or the Pacific, the ship beneath his boots came from Maine steel and Maine hands. A system forged in fire. The next destroyer, USS Chevalier, DD 451, began construction in June. This time, everything was measured, tracked, and improved. The Bath process was no longer experimental, it was mathematical. Workers operated from a color-coded flowchart that mapped every component of the ship to its place in the schedule. Red for hull, blue for mechanical, green for electrical, yellow for armament. If one part fell behind, the entire timeline risked collapse. To prevent bottlenecks, Newell implemented a 24-hour rotating shift, schedule 3 crews, each working 8-hour rotations, so construction never stopped, not for a single minute. The rhythm was relentless. Welders joked they could tell the time by the sound of the cranes. Shift change sounded like thunder rolling down the river. The Admiral returns. By late August, Admiral Robinson returned for inspection. This time, he arrived unannounced, stepping onto the slipway, just as a massive section of the Chevalier's midship hull was being lowered into place. The operation looked like madness, hundreds of men shouting, sparks flying, a 60-ton steel segment swaying from a crane cable like a pendulum. Then, with a hiss of alignment pins and the sound of welders striking arcs in perfect sync, the entire midship section fused seamlessly with the forward hull. No misalignment, no delay. The Admiral turned to Newell, shaking his head in disbelief. "You're building destroyers like automobiles," he said. "I never thought I'd live to see it." Newell smiled faintly, his face lit by the glow of welding sparks. "Neither did I, Admiral, but we don't have the luxury of disbelief anymore. The human cost of perfection." Behind the triumph lay exhaustion. Bath Iron Works had become a crucible of steel, sweat, and sacrifice. Accidents were frequent. A single spark could ignite fuel vapors. A misplaced foot on scaffolding could end a life. Welders developed burns on their arms that looked like constellations of tiny stars. Riveters went deaf from the endless hammering. And every day, the whistle blew again, calling them back to work. But no one complained. For many, their sons and brothers were fighting in the Pacific, aboard ships just like the ones they were building. "Every weld is a prayer," one worker wrote in a letter home. "We can't fight, but we can make sure our boys have something that won't let them down." By December 1942, Bath Iron Works had achieved the unthinkable. Not just one miracle destroyer, but a fleet of them. 9 Fletcher-class destroyers slid down the Kennebec that year, each faster and more efficient than the last. The Chevalier completed in 22 days. The Strong in 19. The Sullivans went on to serve in the Pacific, surviving some of the fiercest naval battles of the war, from Guadalcanal to Okinawa. Every ship carried the same spirit, born of cold mornings, burning torches, and the relentless hum of American industry. But the war wasn't over. By 1943, Japan's navy was still a deadly force, and the Atlantic convoys were still bleeding. The navy now demanded even faster construction, bigger ships, tougher hulls, more firepower, and that meant Bath Iron Works would need to evolve once again beyond even the impossible. The next challenge would push Newell's system, his workers, and his sanity to the breaking point. January 1943, Bath, Maine. Snow dusted the rooftops of the shipyard like powdered sugar, but the air was thick with smoke and urgency. The war had entered its most desperate phase. The Navy's need for destroyers was insatiable. At dawn, the shipyard whistle screamed its metallic cry across the frozen river. The sound rolled over the town, a call that every man and woman in Bath knew by heart, the sound of duty. By now, the Bath Ironworks complex stretched nearly a mile along the Kennebec River, a tangle of steel skeletons, cranes, and scaffolding. Floodlights burned through the darkness 24 hours a day, giving the place the eerie glow of a city that refused to sleep. And at the center of it all stood William Newell, his boots caked in frost and his eyes red from another sleepless night. The miracle man of 1942 had become the reluctant general of an industrial army. The weight of success. The Navy's telegrams were no longer congratulatory. They were demanding. Need 25 destroyers by end of year. Increase output 15%, no excuses. Failure is not an option. Admiral King himself had sent word. The Pacific will be won by steel and speed. Don't let us down. To meet the new quota, Newell expanded the modular process to the breaking point. Instead of assembling one destroyer at a time, the yard now juggled 4 simultaneous builds, each divided into 250 prefabricated sections, each with its own schedule, workforce, and materials pipeline. This demanded coordination so precise that a delay in a single subassembly, a gearbox, a turbine, a radio mast, could throw off the entire sequence. The Bath Shipyard became an orchestra of controlled chaos, where one wrong note could destroy the harmony. January 14th, 1943, Slipway C. A sharp crack echoed across the yard. A support strut on a nearly complete desk hull, 255, USS Taylor BU. For a moment, the yard went silent. Then came shouting, running, panic. The hull section had been assembled too fast. Heat warping from the welds had expanded the steel beyond tolerance. A single miscalculation in timing had undone a week's work. Newell climbed down from the gantry to inspect the damage himself. His face was pale in the torchlight. He didn't shout. He didn't curse. He simply said, "We pushed her too hard." Then he ordered the damaged section cut free and replaced, not repaired. "No shortcuts," he told the crew. "We'll do it again right this time." The setback cost 3 days. The schedule didn't forgive that. Pressure from above. By February, the Navy had begun sending observers, young officers from Washington, to supervise production and report delays directly to the Bureau of Ships. They were despised by the crews, who called them clipboard commandos. One of them, Lieutenant Commander Richard Mason, watched from the catwalk as welders labored over a midship section glowing red from the heat of fresh seams. He turned to Newell and said coldly, "You're running this yard like a factory, not a shipyard." Newell didn't look up from his clipboard. "That's the idea, Commander. We're not building art, we're building survival." Mason frowned. "Survival doesn't matter if your ships crack apart at sea." The two men locked eyes. Neither blinked. That night, Newell returned to his office and wrote one line in his journal. "The Navy thinks we're machines. They forget machines break too." The workers' war. The human toll was mounting. Workers collapsed from exhaustion. Some went home only to sleep a few hours before the next shift. Husbands and wives passed each other at the gates, one leaving as the other arrived. Accidents increased. The frozen decks were treacherous, the machinery unforgiving. When a crane cable snapped and dropped a section of hull plating, killing 2 riggers, the entire yard fell silent for a day. The next morning, at dawn, a hand-painted sign appeared on the main gate. "For the men who fell, we build faster." It was grim, but it was real. In Bath, every rivet was a small act of vengeance. Meanwhile, in the Pacific, while Bath's workers toiled in the snow, their creations were already fighting halfway across the world. The destroyers, the Sullivans, Strong, and Chevalier, had joined Task Force 39 under Admiral Halsey. Their job, protect carriers and convoys through the nightmare waters of the Solomon Islands. Reports filtered back through Navy channels glowing, almost unbelievable. The destroyers built in Maine were outperforming expectations. Their welds held, their turbines ran flawlessly. Their radar systems, assembled by factory women who'd never been to sea, were detecting Japanese aircraft before the enemy even saw them. On April 7th, 1943, USS Strong downed 3 attacking dive bombers off New Georgia, a feat that made front-page news. When word reached Bath, Newell pinned the article to the workshop bulletin board. It read, "Bath destroyers turn the tide in the Pacific." Below it, he wrote in chalk, "You built that. June 1943, the line blurs." By summer, Bath Iron Works was producing destroyers faster than any shipyard in history. From keel laying to launch, the average build time had dropped to just 20 days. The Navy called it the Bath Miracle. To the workers, it was simply the grind. Even so, morale was strangely high. Patriotism burned hotter than fatigue. On the 4th of July, crews hung a banner from the gantry crane that read, "Our fireworks go to sea." That same month, the USS Chevalier returned to port after 7 months of combat, scarred, battered, but alive. Her captain sent a letter to Bath. She took 3 near misses and 1 direct hit. "We lost men, but the ship never failed us. Whoever built her, tell them they saved 200 souls." Newell read the letter aloud to his crew, his voice trembling. Then he said quietly, "This is why we can't stop." The breaking point. But as 1943 wore on, the relentless pace began to consume him. He was sleeping 3 hours a night, eating at his desk, sketching design improvements on scrap paper. His hands shook from coffee and fatigue. During a midnight inspection in September, he collapsed on the deck of a half-built destroyer. Doctors called it industrial exhaustion, what today would be known as burnout. When he woke in the infirmary, his assistant foreman, Jack Connolly, sat beside him. "You've built an empire of steel, Bill. Don't let it kill you." Newell smiled faintly. "If it keeps one more sailor alive, I'll take that trade." 3 days later, he was back at work. By December 1943, Bath Iron Works had launched 16 Fletcher-class destroyers, each a masterpiece of industrial precision and human grit. Admirals who once doubted the yard now visited it as a pilgrimage site. Reporters called it America's Miracle Factory. But for Newell, the real miracle wasn't the ships, it was the people. "We turned farmers into welders, clerks into riggers, and mothers into machinists," he said. "And they built a fleet that no empire on earth can sink." As the new year approached, the Atlantic was beginning to tilt in the Allies' favor, and the Pacific was roaring back with American steel. The shipyard had given the Navy its teeth. But what came next in 1944 would test whether the Bath process could stand up to the full weight of global war. Because the Navy was about to demand something even more audacious, a destroyer esquadron every month. January 1944, Bath, Maine. Snow blew in heavy curtains across the Kennebec River, muffling the clang of hammers and the shriek of cranes. The war had reached its peak. The Pacific was a cauldron of fire, the Atlantic a graveyard of ships. And yet, in this frozen corner of New England, men and women worked through the blizzards as if the world depended on them. Because it did. Inside the shipyard office, a telegram from the Bureau of Ships lay open on William Newell's desk. Its message was short, brutal, and clear. New requirement, 12 destroyers per quarter. Priority code red. Production, to match West Coast yards immediately. Newell stared at it for a long time. His eyes were sunken, his hair grayer than the year before. Across the room, his assistant foreman, Jack Connolly, leaned against a steel filing cabinet. 12 per quarter, he muttered. They might as well ask for the moon. Newell exhaled slowly, tapping the telegram against his palm. Then we'd better start building a ladder to reach it. The blueprint for a miracle. The key, Newell realized, wasn't just speed, it was standardization. Until now, each Fletcher-class destroyer, though based on the same design, had minor variations, different fittings, layouts, or configurations depending on the available materials or subcontractors. That individuality had been fine in peacetime, but in war, it was inefficiency disguised as craftsmanship. So Newell made a radical decision. Every new ship leaving Bath would be identical down to the last bolt. Same hull geometry, same wiring layouts, same radio racks, gun placements, even paint formulas. It was the Ford Model T philosophy applied to a 2,000-ton killing machine. The new slogan appeared on every workshop board, every ship a twin. He gathered his engineers around a massive drafting table one evening, the air thick with cigarette smoke and fatigue. "We're not building destroyers," he told them. We're building templates for victory, each one faster than the last. The engineers exchanged glances, half disbelief, half awe, but no one questioned him, not anymore. The rhythm of war. The transformation was immediate. Production bays were reorganized into zones, each specializing in a particular module. Zone 1, bow and foredeck construction. Zone 2, machinery spaces and engine rooms. Zone 3, midship armament and living quarters. Zone 4, superstructure and radar installation. Each zone operated like a mini assembly line, feeding into the slipway where the ship took shape section by section. By March 1944, Bath Iron Works was producing a destroyer hull every 18 days and finishing one complete warship every 29. The results stunned the Navy. Admiral Robinson, now Chief of Procurement, called Bath's monthly output industrial sorcery. But for the workers, it was no magic. It was sweat, precision, and the rhythm of torches and steel. Bath by night. From above, the shipyard at night looked like a city of stars. Every arc welder's torch was a tiny sun, flickering through the blizzard. The noise never stopped. Even in the darkest hours, you could hear the hydraulic hiss of cranes, the clang of hammers, the murmur of voices carried by the wind. In the cafeteria, the night shift ate under flickering lights, thick stew, black coffee, cigarettes dangling from cracked lips. There was laughter, too. Gallows humor, jokes about how the Navy's tin cans could outlast any marriage in Bath. Pinned on the wall was a growing collection of letters from the Pacific. USS Strong still fighting. You built her right. USS. The Sullivans took a bomb and lived. Thank you. USS Taylor, fastest ship in the squadron. Feels like she wants to fly. The letters reminded them why none of them had seen a real sunrise in months. June 1944 D-Day. When the news came that Allied forces had landed in Normandy, the entire yard froze. Radios played the crackling broadcasts as men and women stood in silence, faces streaked with grease and tears. Every destroyer that had guarded those invasion ships, every escort that had shelled German positions off Omaha Beach, many had been built right here in Bath. The USS Corrie, USS Fitch, and USS Hobson Bath-built Fletcher-class destroyers formed part of the naval shield that unleashed Operation Overlord. When the Corrie struck a mine and went down with 24 sailors, the shipyard's flag flew at half-mast. But the next morning, the whistle still blew at dawn. As one worker put it, if they can fight in the Channel, we can fight the cold. The Admirals visit. In August 1944, Admiral King himself arrived in Bath. It was the first time the US fleet commander had left Washington for a shipyard tour since the war began. He walked through the sheds, the steel dust clinging to his polished shoes. He watched as welders, men barely in their 20s, women barely out of high school, fused together the backbone of the Navy. When the latest destroyer, USS Shields, DD 596, slid into the river, the entire yard erupted into cheers. King turned to Newell. "You've done something no Navy in history has managed," he said. "You've made warships faster than we can find sailors to man them." Newell smiled, his voice hoarse from exhaustion. "Then I'd say that's a good problem to have, Admiral." King nodded, and for a rare moment, the hard-nosed commander allowed himself a smile. "History will remember this yard," he said quietly, "and the men who made it roar. The price of efficiency, but with triumph came loss." Newell's health deteriorated rapidly through the fall. Years of sleepless nights and constant stress had taken their toll. His hands shook from tremors caused by fatigue and overwork. When the USS Taylor returned from the Pacific with shrapnel scars and battle ribbons, Newell was too weak to attend the celebration. From his office window, he watched the ship's grey silhouette glide upriver, steam curling from her stacks. "She's still afloat," he whispered. "That's all that matters." By winter, he had stepped back from daily management, replaced by his deputy Connolly. But his methods, his system, now ran the yard like clockwork. The Bath process no longer needed its creator. It had become self-sustaining, a war machine that could run without sleep, without pause, without doubt. 1945. Victory's shadow. As spring came to Maine, victory was finally in sight. The Pacific was closing in on Japan, the Atlantic U-boats were hunted to extinction, and the world was shifting from desperation to triumph. Bath Iron Works had built 83 destroyers by the war's end, each one a symbol of American determination, each one bearing the scars of the men and women who forged them. When news of Germany's surrender came, the yard erupted into chaos, workers cheering, horns blaring, welders tossing their gloves into the air. But Newell didn't join the celebration. He sat alone in his office, staring at a faded photograph on his desk, USS the Sullivans, cutting through the Pacific waves. 16 days, he murmured. That's how long it took to change everything. Outside, the Kennebec flowed steadily toward the sea, carrying with it the echoes of steel, sweat, and thunder. Epilogue: The Legacy. After the war, Bath Iron Works returned to peacetime production, but the legend of the 16-day destroyer became part of naval lore. William Newell retired quietly in 1948. When asked by a journalist what his proudest moment had been, he didn't mention records or awards. He simply said, "The day we built faster than the war could destroy."